Hi, in this video we present our work, Accurate Detection using High-Resolution Cascaded MIMO Radar. Recently, there has been a significant amount of work on leveraging millimeter wave radars for imaging and object detection in autonomous driving. However, obtaining semantic scene understanding from radar images is challenging because the angular resolution of radar is extremely low. As one can see from these examples, low-resolution radar heat maps appear as blobs of radar reflections with no sharp boundaries or shapes of the objects. In this work, we introduce Radatron, a millimeter wave radar-based object detection system that can capture radar heat maps with 10 times higher angular resolution, so that even the silhouettes of the car are almost visible. Using these high-resolution radar heat maps, Radatron is able to accurately detect the precise bounding boxes of vehicles. Radatron achieves high angular resolution radar imaging using cascaded MIMO radar. This radar system combines 16 receivers and 12 transmitters to emulate a large virtual antenna array in order to improve the angular resolution. However, while enabling high resolution, the cascaded MIMO radar also introduces a unique challenge, especially in dynamic scenes. Because the multiple radar transmitters take turns to transmit, but the scene might have already moved during the transmit time interval, which leads to motion-induced distortion. Due to the nature of millimeter wave radar waveforms, even a small displacement can cause the moving objects to be smeared and appear in different locations than where they really are. We overcome this challenge through a hybrid radar processing and deep learning approach. On the radar processing front, we designed a motion compensation pre-processing algorithm, which estimates and compensates for the motions in the scene during the transmit time interval. Although the motion compensation algorithm can alleviate the distortions to some extent, it's not perfect. To further correct for the residual distortions, we leverage an insight that although heat maps created using a single transmitter have lower resolution and artifacts, it does not suffer from motion-induced distortion. Therefore, we designed our network model to jointly leverage the high and the low-resolution radar heat maps to achieve accurate detection using the cascaded MIMO radar while combating the motion-induced distortion artifact. We adapt the faster RCNN framework in Radatron's network architecture, but we designed the backbone network to have a two-stream architecture, which takes as input both high and low resolution versions of the radar heat maps, and we fused the two versions feature maps in the middle of the backbone network. Next, we show a demo video demonstrating the performance of Radatron in our urban street dataset. We show the per-frame detection results without any temporal post-processing. The field of view is up to 25 meters, so further away objects will not appear. As you can see, Radatron is able to accurately detect vehicles on the road, even in complex scenarios with multiple cars around. It can correctly capture the changes in orientation as the cars are turning in the intersection, which is the bottleneck when using low-resolution radars. Radatron can also accurately detect vehicles moving towards the radar, even though the relative speed can lead to severe motion-induced distortions. For more details, please refer to our paper. The code and dataset are also available on our website. Thank you very much for watching.